Hi everyone, today we'll be discussing the LeetCode problem of the day, largest triangle area. In this problem, you are given a few points in the xy plane, point 2D array, which is x coordinate and y coordinate, and you just have to return the largest area that can be formed using any 3 points in the of the given points. So if you see the first example, we have this triangle and the length, the base is 2 and the height is 2, so the area would be half into 2 into 2, which is 2. And for the second example, if we just plot it, points are at 0 0 1 0 0 1 1 0 and 0 1. So in this triangle we can see that base is 1, height is 1, and the area would be half into 1 into 1, which is 0.5. Also, it is not guaranteed that all the points will lie in the axis only. So we can also have the points anywhere in the plane, and we just have to pick any 3 points and return the maximum area of the triangle. Now coming to the approach, we have points in the 2D plane, and we have to pick any 3 points and find the area of the triangle. And among all these 3 different points, we just have to return the maximum area. So suppose we have a plane and we have some random 3 points, x1, y1, and another point might be here, x2, y2, and another point is here, x3, y3. So these 3 points will form a triangle, and to find the area of this triangle using a points, we can have a formula like this: x1, y1, x2, y2, x3, y3, and the same point again, x1, y1. So we know that we can just do the shoelace multiplication to get the formula. So x1, y2 minus x2, y1 plus x2, y3 minus x3, y2 plus x3, y1 minus x1, y3. So this multiplication, the absolute value of this multiplication divided by 2 will give us the area of the triangle. So let me just write it here. So x1, y2 minus x2, y1 plus x2, y3 minus x3, y2 plus x3, y1 minus x1, y2. We have 6 terms here, so let's just simplify it by taking a few terms common. So if we take x1 common, then we have x3, y1 minus x1, this is y3. So we take if we take x1 common, we will get y2 minus y3, and if we take x2 common, we will have y3 minus y1, and if we take x3 as common, then we will have y1 minus y2. So this multiplication, the absolute value, and when we divide by 2, this will give us the area of this triangle. So the solution is just iterate on all possible triplets of points and calculate the area and return the maximum area amongst all these possibilities. Now coming to the code, first let me declare a double variable to store the answer. In the answer, the area can be, it is not an integer, it can be in double, so that's why we are using a double variable. Now let's just iterate on all the points. I less than points dot length I plus plus, and then j equal to, j starts from I plus 1 to avoid the duplications, and j less than points dot length k plus plus. Now again third point, and this point starts from j plus 1. Point start length k plus plus. So now let's just create all the 3 points. X1 equal to points of I0, and then Y1 equal to points of I1. Let's repeat the same thing for point 2 and point 3. Points of J, Y2, points of J, and the third point is X3, and it is from points K, Y3 from K. Now we have the 3 points, and let's just find the area. We can just copy this. We had the formula previously. And also take the absolute value of this. So we can use math.abs divided by 2.0. We use 2.0 because we want the division to be in double. Otherwise, this division will be in integer. And once we have the area, let's compare it with our answer. Answer equal to dot max answer comma area. And at the end, just return the answer. So let's see. Okay, points dot length. I think the same thing for j equal to I plus 1, j less than. Okay, for int j equal to I plus 1, and similarly for k as well. Let me submit. Yeah, and it works. Coming to the time and space complexity analysis. First, for time complexity, since we are iterating on all possible triplets and we are running 3 loops, the complexity will be order of n cube. And for space complexity, we are not creating any additional arrays or such. We are just creating answer variables and some iterators. So the space complexity will be constant. So it's order of 1. And I also have the code in Python. If anyone wants to view it, I'll add it in the description as well. And let's catch up in the next video.